today we're going to go through and we're going to kind of start our trig unit. It shouldn't really take more than this week. Today we're going to deal with angles and angle measures. There's really three main things we're going to discuss today. Three. And then tomorrow you're going to take that quiz after we go through the fourth thing that's on here. And then, or a test. And then on Wednesday we're going to talk about the Pythagorean theorem, which I know that you're all familiar with, right? And then SOHCAHTOA, which you're kind of familiar with, right?
Oh, yeah.
Sine,
Yeah.
cosine, and tangent, right? You are kind of familiar with that. So that'll be Wednesday. Thursday will be something. I can't remember. But anyways, should be pretty simple as far as, you know, this stuff goes. All right. So everybody paying attention, right? Phones away. Brains turned on. Ready to go. Yes, ma'am.
Missing work yet?
You can give it straight to me right now.
Right now? Or
Like-
after class?
Like where we are right now and the fact, don't put it over there, just give it straight to me at this point.
Okay.
That way it'll get done faster. Okay. Oh, there you go.
I haven't done. Do you want it?
Yeah, I guess. Just make sure you want to skip it. Is this for you to keep too, though?
No.
You don't need
She's wrote it on there.
Okay. Okay. So here we go. First, we have a, what's this called? Coordinate plane. Good job. So we're talking about this coordinate plane, right? Hey, are y'all with me? I feel like I got some chatters. All right. So everything that we're going to talk about today, well, not everything, but most of these angles that we're going to refer to today have a beginning. And that beginning is the positive x-axis. Okay? The positive x-axis. We're going to talk about that in just a minute. But before we talk about that, I want to talk about all four of these places in this coordinate plane. We call them what? Starts with a Q. We call them quadrants. And you know where the first quadrant is located?
Top right.
Top right. I like to think of it as positive, positive. Positive, positive, where it all starts. This is quadrant 1 right here. Any angle measure that lies inside quadrant 1 would lie between 0 and 90 degrees. Okay? Now, which direction do we go to get to quadrant 2? Let's not say left. Let's say counterclockwise. So, counterclockwise puts me over here, and you're right, to the left. And that is quadrant 2. That ranges every degree measure between what? 90 and 180 degrees. Okay? Then we keep on coming around. This is quadrant 3 from 180 to 270 degrees. Finally, finishing us off at quadrant 4, which is from 270 degrees to what? 270 to 360. So right off the bat, we know that that positive x-axis, not only is that considered 0 degrees, it's also can be considered what? 360 degrees. Which really it's out of order, but that's okay. At the very bottom of this, one full revolution around a circle is how many degrees? And y'all know that, right? That's not something new you're being told right now. Now, as far as the angle measure, so I go back over here. The angle that is created is shown with that little, I guess you'd call it like a little loopy line. That's the angle that this is particularly discussing for the questions that we're going to, or the blanks that we're going to fill in over to the right. When we talk about where it begins, that positive x-axis, we call that the initial side. That's where it begins. That's the initial side. It's the side that the ray is, the origin is on the beginning of that ray, and it goes up that positive x-axis. That is the initial side. The other ray, where it finishes, is called the terminal side. The terminal side. If we're talking about angles around this coordinate plane, any counterclockwise rotation results in a positive angle measure. But if we go clockwise, it's going to be what? Negative. Okay, so think about this for a minute. Use your logical abilities. If I said negative 90 degrees, where do I start? Same place, right? The positive x-axis. But if I want to go negative 90 degrees, which way do I go?
Clockwise.
I go clockwise. And it lands me where? On the same line that's 270 degrees, right? So could you say that 270 degrees and negative 90 degrees is equivalent? Absolutely. Okay, we'll do one more. Let's say I said negative 180. Again, I start at the same place every time. I go clockwise. Where do I end up landing? Right on top of, If I went negative 180 degrees,
You land right on top of 180.
I land right on top of 180 degrees. So could I say that 180 and negative 180, same location? That's called something. In fact, we're going to talk about it in a minute. So on the back side, those are called coterminal angles. They're called coterminal angles. Now, we'll also discuss this in a minute. How far is 180 from negative 180? How far away is it? It's 360 degrees. You can do the subtraction. 180 minus negative 180. 360 degrees. How far is 270 from negative 90?
360.
360 degrees, right? All right, we'll talk about that in a minute. Now, when it comes to sketching angles, very simple, right? So here's what I want you to tell me. Number one, what quadrant is 75 degrees located in? Definitely quadrant 1, right? Is it closer to 0 or is it closer to 90? Definitely closer to 90, so do your best. Okay, it doesn't have to be perfect, but I would say that's pretty close, right? So we're talking about this angle right here, 75 degrees. Okay? How about negative 160? What quadrant would that be located in? Quadrant 3. Quadrant 3, right? Because I'm starting same place, but I'm going clockwise, and I don't quite make it to what? I don't quite make it to negative 180. So I kind of make it to about right in here. Does that look pretty good, y'all? Doesn't have to be perfect, but negative 160 is right here. Quadrant 3. Pretty simple, right? Last one, 430 degrees. Well, for sure, I'm going all the way around, aren't I? Which is how far? 360. So how do I figure out where I need to go from here?
Subtract 430 minus 360.
Right? What's 430 minus 360?
70.
So I'm going to simply draw a 70-degree angle to the best of my ability. It doesn't have to be perfect. I don't usually get a protractor out. And that would be my 430-degree angle. So one more time. One more example. 430 would be equivalent to what? 70. How far is 430 from 70? 360 degrees. Okay? See, 430 and 70 would be, in a way, equivalent angles. Why? Because they're in the same quadrant. They're even bigger than that. They're in the same, starts with L. They're in the exact same location. They're in identical locations. Not just quadrant 1. I'm saying they're exactly the same spot in quadrant 1. Same location. Okay? Very simple. Now, I want to show y'all something. Let's say that we are dealing with what we call a unit circle. And we're going to talk about this. We're going to refer to unit circles even more. Basically, what we know about a unit circle is your radius is 1. All right. Anyways, I want you to, just for a moment, picture this as far as a coordinate plane goes. What would be the full distance around this unit circle based on what we just talked about? 360 degrees. Y'all agree? Now, listen. What if I'm gonna erase this. What if I took some scissors and I cut it right here? And then I took this line that goes all the way around and I straightened it up and I got a ruler and I measured it. Is that 360 degrees? No, 360 degrees is the degree measure around that circle. But if I cut it, lay it out, and I measure it, what is that measurement? Huh? Nuh-uh. If I take that full circle, cut it, lay it down, and measure it, what's the measure? We call it, starts with C, circumference. We call it circumference. And there were two good measurements for circumference that we talked about. We talked about pi d, pi times the diameter. But the one that I think we say the most, we say what? 2 pi r, right? We say 2 pi r. Are y'all familiar with that, or am I speaking another language right now? 2 pi r. Now listen, if this is a unit circle, r is 1. So therefore, 360 degrees as a degree measure would be equivalent to what as a radian measure? Radian simply meaning the physical distance around that circle. What would it be? If your r is 1. If your r is 1. 2 pi r, 2 pi times 1 is, let's say 2 pi. Let's just leave it 2 pi. Y'all agree? So 360 degrees as far as the degree measure around the circle is equivalent to 2 pi as far as a radian measure. Are you with me? You're not? Okay. Like I said, if I were to take a circle, right? All the way around that circle is 360 degrees. But like I said, I cut it right here, and I take this line that makes that circle, and I just lay it out flat. That has a value as well. You measure it. And you measure that value. It all has to do with this unit circle. And that unit circle uses the radius to find it as 2 times pi times r. But since r is 1, the value of that distance around that circle is 2 pi. 360 degrees is equivalent to 2 pi. Okay? 1 is the degree measure around. 1 is the physical distance of that circle around. Brayton, what was your question?
Why can't you just put equal like 360?
Because 360 is only talking about the angle measure. But sometimes we want to know not just the angle measure, but the physical distance around that circle as well. 2 pi.
That's just not geometry.
It is, kind of. But there's some things that we also have to talk about in Algebra 2 that are geometric. Yes?
So if the radian's like 5 or something, you would have to do 2.
If the radius was different, then yeah,
You would do the r.
it would be 2 times pi times 5, 10 pi. But we're talking in here about a unit circle where your radius is 1.
So it's pretty much always gonna be 1.
In what we're doing, for sure. Okay, in what we're doing. All right, now, listen. If 360 degrees is 2 pi, what would 180 degrees be? It would be 1 pi. right? It'd be 1 pi. Here's the point. What we're going to do is we're going to be converting degrees to radians or radians to degrees. Okay? Sometimes I need to know what the degree measure is of this portion of the circle. Sometimes I need to know what the actual arc length is of that particular portion of the circle. Degrees versus radians. So if I want to convert a degree to a radian, I multiply it by pi over 180. So for example, I got a 30 degree. I want to figure out what that would be as a radian. What do I multiply by? Pi over 180. But we're going to leave this in what we call in terms of pi. Think about this. When you think of pi, what's the number that comes to your brain first? 3.14, right? But is 3.14 the actual value of pi? No, it keeps on going forever, right? So therefore, if I say pi is 3.14, I'm rounding. So we leave it in terms of pi, meaning we don't round it. So here's what I'm going to do. I'm going to leave pi alone, and I'm going to use my calculator, and I'm going to break down 30 over 180. So go to your calculator. What's 30 over 180 become? 1 over 6. So 30 degrees as a radian is 1 pi over 6. But do I really need 1 pi? Or can't I just put pi over 6? Yes. So 30 degrees is equivalent to pi over 6 radians. Very simple. Okay, 150. Multiply it by pi over 180. That's what we do. But remember, we're going to leave pi alone. We're going to leave it in terms of pi. So what do I care about doing here? 150 over 180. And you're going to let the calculator break that down to what? What'd you get? 5 over 6. So my answer is 5 pi over 6. Is this hard?
No.
So negative 220, I'm going to multiply by pi over 180. I'm going to ignore the pi for a moment. I'm going to type in my calculator negative 220 over 180. And I'm going to let it break it down for me. What does negative 220 over 180 break down to? Negative what? Negative 11 pi over 9 is my answer. Because you got a negative 11 over 9. Now, what do you think I do to convert a radian to a degree? Yep, I flip it. And sure enough, what's going to happen because I multiply by 180 over pi now? What's going to happen? What do you notice? You've got a pi where? In the numerator and the denominator. So what will they do inevitably? They're going to cancel. So we let them. That's what's going to allow it to change into a what? A degree. So all I care about is what's 4/3 times 180. So go type it in. You don't have to do it in your brain. 4/3 times 180.
240.
So 4 pi over 3 is equivalent to 240 degrees. One's a radian, one's a degree. Do you understand? Next, we're going to multiply by 180 over pi. We're going to let our pi's do what? And you're going to type in your calculator. Negative 5 over 36 times 180. Negative 5 over 36 times 180 equals?
Negative 25 degrees.
Negative 25 degrees is my answer. Last one, we're going to multiply it by 180 over pi to change it from a radian to a degree. We're going to let those pi's cancel, and you're going to type in your calculator. 7 over 4 times 180. What do you get?
315 degrees.
So that's the first thing today. Converting degrees to radians, radians to degrees. Not rocket science. Can y'all do it?
Can you go back to like 4 through 5 and go through the steps? Because I got kind of lost.
Were you on your phone then?
No?
Okay. Because I've seen you on your phone a little bit. So what we're going to do is we're going to change it from a degree to a radian by multiplying by pi over 180. So the pi, we just leave it be. You just go ahead and drop it down. So our focus really is just 30 over 180. So you go to your calculator, literally just go 30 over 180, let it reduce. It reduces to 1 over 6. So basically my answer is 1 pi over 6. You with me? So same thing with pi. I'm going to multiply 150 by pi over 180. I'm going to ignore the pi. I'm just going to let it come down. We're going to leave it in terms of pi.
Okay, I was doing 30 divided by 180, not in the fraction.
Oh yeah, use the fraction and just let it break down. Okay?
So for number 5, you just do 150 over 180.
You got it.
Okay.
And that'll be 5 over 6, so we do 5 pi over 6. Cool?
Yes.
All right, now, backside. And we've already talked about this, so this is a very simple concept. Remember what we said about where negative 90 was equivalent to what? What did we say negative 90 was equivalent to? 270. What did we say negative 180 was equivalent to? 180. What did we say 0 was equivalent to? 360. And you remember that 1? What did we say 430 was equivalent to? 70. They're all the same because they're in the same location. Those are called coterminal angles. And every single one of those were how far from each other? 360 degrees. So, this particular group of questions ask us to find two coterminal angles. One that is positive and one that is negative given one of your angles. So, for example, it tells me, hey, you've got an angle that's 65 degrees. Find me a positive coterminal angle. Well, guys, where is the next positive coterminal angle with 65? It's 360 more degrees. You're going back around the circle until you get back to that same location. That's the next positive coterminal angle. So what is 65 plus 360? That, I promise, is located in the exact same location as 65 degrees. You just had to go around once. Now, could I come up with another negative coterminal angle with 65? How do I come up with the negative one? You subtract 360. Can y'all do that? What's 65 minus 360? I promise that the angles 65, 425, and negative 295 are all located in exactly the same spot. They're all in quadrant. They're all in quadrant 1. I guarantee it. All of them. They're in the same spot. All in quadrant 1. Okay? So, number 11. Number 11, I would actually not even add 362. You could. If you add 360 to 540, you'll find another coterminal angle. But because it's bigger than 360, I'm actually just going to subtract 360 twice. What's 540 minus 360? 180 degrees, right? And then what's 180 degrees minus 360?
Negative 180.
Negative 180. We already talked about those two, didn't we? I promise you that 540, 180, and negative 180 are all in the same location. They're coterminal angles. Now, go back to the last, or the front side. What did we say 360 as a degree was equal to as a radian? What did we say 360?
2 pi r.
But we limit it because r was 1. We limit it to simply
Oh, d.
2 pi.
Oh, okay.
Right? 2 pi. Here's the point. Look at number 12 and 13. Are those in degree form or in radian form? If I want to find two coterminal angles in radian form, I simply add and subtract what? 2 pi. Now listen, y'all have done 3x plus 5x before, right? What is 3x plus 5x?
8x.
8x. Your variables stay the same. When I do 13 pi over 18 plus 2 pi, what are we going to just let stay the same? Pi. Pi will just stay the same like x did. So what's my real focus then to try to solve this problem? What's my real focus, guys? 13 over 18 plus 2. You don't need to type pi in your calculator. Okay, don't. We're leaving it in terms of pi. Don't touch pi in your calculator. Just do 13 over 18 plus 2. What is 13 over 18 plus 2? What'd you say? So 48 over 8. Did that not reduce some?
49 of it.
49.
I thought, is it 49?
Yeah, it's 49.
Can't read. Your glasses. You need stronger prescription. So it's 49 over 18. So what are we writing? We're writing 49 pi over 18. That's the next positive coterminal angle. How do I find the next negative coterminal angle? Subtract 2 pi. It's just like subtracting 360. We leave pi alone and we type what in our calculator? 13 over 18 minus 2. What do you get? Negative 23 over 18. So we write negative 23 pi over 18. That's how we convert and get a positive and a negative coterminal angle. Real simple. Let's do this one real fast. So we got 14 pi over 9 plus 2 pi. What? What are you doing? Plus 2 pi. We're going to leave the pi alone. And we're going to do 14 pi over 9 minus 2 pi. We're going to leave pi alone. So who's got 14 over 9 plus 2? 32 over 9. So it's 32 pi over 9. And then who's typed in 14 over 9 minus 2? Negative 4 over 9 is what it said. So negative 4 pi over 9. Done. So we've talked about 2 things so far. One, we've talked about, I forgot what did we, my brain just went. Oh, yeah, converting. Converting degrees to radians, radians to degrees, right? 180 over pi or pi over 180. We've also talked about coterminal angles, finding a positive one or negative. You add 360 if it's a degree, subtract 360. You add 2 pi or you subtract 2 pi if it's radian. Very simple. Last thing is reference angle. Reference angle. So look at this with me. I'm going to give it a fail-safe, you cannot miss these, to find the reference angle. So first, I'm going to talk about the positive x side. You see, when we talk about reference angles, we're talking about how far they are from the x-axis. One more time. When we talk about reference angles, we take our degree and we find, Ava, how far it is from the x-axis. Okay? What are we finding?
How far it is from the x-axis.
How far it is from the x-axis. So let's start with this x-axis right here first. 1, the easiest, is if that angle is up here in your first quadrant. How far from the x-axis is it? Well, it is itself. Okay? That's easy. It is itself. That's how far it is from the x-axis. Itself a far away. So if it's 40 degrees, how far from the x-axis is it? 40 degrees. If it's 65 degrees, how far from the x-axis is it? It's 65 degrees. So if it's in quadrant 1, whatever it is, that's your reference angle. You got me? Now, quadrant 4. In quadrant 4, let's say it's 310 degrees. Well, it's how far away it is from 360. So you would simply subtract it from 360. So 310 would be 50 away from 360. So the reference angle would be 50 degrees. You with me? Now, you have one other spot right here. And what's this value of your x-axis? 180. So if we're talking about how far it is from that axis, here's what we do if it's in quadrant 2. We subtract it from 180. But if it's in quadrant 3, we don't subtract it from 180. What do? We subtract 180 from it. Does that make sense? Huh? All right, let me show you a couple of examples. Not even a second. That's the my parent. I almost signed it. I almost signed it. Almost parent.
He's lying. I
No,
was
I'm
there.
not, bro.
Is he lying?
Yes.
He was,
No, I'm not.
All right. What quadrant is 225 in? Guys, what quadrant is 225 in?
3.
Okay. Is it closer to 180 or is it closer to 270? It's actually right in the middle. Isn't it?
270.
Right in the middle. So let's say it's right there. Guys, remember, reference angle is how far it is from the what? X-axis at its closest location. That's right there. What is that angle of that x-axis right there? 180. But 225 is above it, so we're going to subtract 180 from it. What is 225 minus 180? So, if my angle is 225, the reference angle is 45. That's how far it is from the x-axis at its closest location. Are you with me on this? So look at this next one. And I kind of ruined this when I did it. 310. What quadrant is that in? It's over here in quadrant 4. It's a little closer to 270 than it is 360. But we're talking about the reference angle, meaning how far is it from the what? X-axis. So when it's in the quadrant 4, we subtract it from 360. What's 360 minus 310? So the reference angle is 50 degrees. You with me on that? It's pretty simple, right?
So you just subtract from whichever x-axis is closest to.
Absolutely. If it's in the first quadrant, though, it's itself. But yeah, quadrant 4, 360 is the closest. Subtract it from it. Quadrant 2, 180 is the closest. Subtract 180. Subtract it from 180. Quadrant 3, it's closest to 180. Subtract 180 from it. Yep, that's it. The reference angle is all about how close it is to the x-axis. So last one, remember, it's called reference angle. And right now, is that an angle? So you know what we know how to do? We know how to make it an angle. We know how to convert it to an angle. How do we convert a radian to an angle? To a degree? Multiply it by 180 over pi. The way you should remember this, because y'all are smart, the way you should remember this, what do I need pi to do? I need it to cancel. Where does pi need to be to cancel? The bottom. So I multiply by 180 over pi, which will allow that to happen. So I go to my calculator, I do 2/3 times 180, and I get what? Where is 120 degrees located, quadrant-wise? It's in the second. Is it closer to 90 or 180? It's a little closer to 90. Let's say it's right around in here. But Jonathan, we're talking about the reference angle, right? So what do we say? It's how far it is from the x-axis. And that x-axis on that side is what? 180 degrees. So what's 180 minus 120? So the reference angle is 60 degrees. Does that make sense? Okay. So that is where we're going to stop today. You got 18 problems for homework. 12 of those, Ava, is converting a degree to a radian or radian to a degree. It should take you 5 seconds. Maybe not 5 seconds. But it shouldn't take long. Y'all should be able to go pretty fast on that. The last 6 problems, you have to do coterminal angles and reference angles. Okay? You feel lonely without that shit. Not making jokes lightly. Trying to concentrate. 18 problems not that good. You almost broke down right there. I saw it in your face.
I wish I would've gotten the same.
He's a healthy poor guy.
I know, me too.
Dude, it's so hard to write left-handed.
No, I know.
It takes so long.
It's tough. Uh-huh.
Hey, come back.
If you'd rather do that, yeah. If you don't like the degree and you want to change it to if you don't like the rating and you want to change the degree, that's fine.
Which ones do you want us to do?